Okay, first, what you have to do is you have to go to this icon and double click on it. I think you are a bit familiar with this by now. Right. So I'm going to open up a new script. So this is for today's lecture. Before anything, what I'm going to do is I'm going to rename this and save it. I'm going to save only the script file, which I'm interested about. So I go to File, Save, or otherwise I can simply use this icon. So I give a location. I'm going to give the name and save. So that is how you save the document. When you close it only, not after minimizing, but when you close it fully, you would be getting your R script somewhere saved in the location that you gave. Okay. So today we are going to discuss generating pattern data, arbitrary data, and some from removing not available values, NA values, and subsetting, some cohesion. Okay, I'll tell you what. So today we are going to learn simple stuff like that. So y'all can, I can give you time. You can open up RStudio and save your file with whatever the name that you want to. Because you can write it with me. Tell me when you're ready. Okay, are you ready with your script saved in your machine? Any difficulty? Because we have to go step by step. You can either put it in the chat room. If you are okay, you can put okay in the chat room if you don't like to speak.
Okay, ma'am.
Okay, good. One is up.
Okay, madam.
Right.
Okay, madam.
Okay, madam.
Okay, right. Okay, cool. Anyone who couldn't do it? Is there anyone who couldn't do it? No. Right. Okay. Good. So you all know how to save file by now. So we are going to generate pattern data. So we are going to start off from the simplest way. If I asked you to generate a vector of values from 0 to 10, how are you going to do that? I don't ask you to assign it to any variable, just to generate values from 0 to 10. There are a couple of methods. Which method are you going to use? So if it was me, I'm going to use 0. This colon mark gives you up to, starting from 0, including 0 to 10. So this is basically how I'm going to generate numbers from 0 to 10. And I'm going to run that. Here I got 0 to 10. There's another method of doing it. See what? Still, you will be getting 0 to 10. Sorry, you have to include 0. Okay, still you will be getting 0. I'm going to clear this off and run it once again. So these are the two methods basically that you have in generating data from a particular value to another value, including those two values, right? So these are generating integers. You can try it. But at the exam, if I ask you to do this, use the simplest method, right? It's not wrong to write a statement like this, but it's a waste of time if you keep on writing this, right? It's a waste of time, and it is quite obvious that you can simply give this command. So this command basically means starting value to the ending value. So that is how you generate. Right. I want to generate values from 10 to 0. The other way around. How are you going to do that? 10 to 0. Starting value to end value. Let's see what this will give us. See, it's giving us the expected response, 10 to 0, right? So what you have to learn here is when you give a syntax like this, right? Always the first component is the starting value. So I'm going to put a comment on that, right? First component is, so I'll write it here. Starting value, semicolon, ending value, right? So now this is done. Even you can use this method, first component comes first. You can type and see. Okay, we'll move a little bit ahead. So it doesn't have to be 0 and 10 all the time. You can either give from 15 to 5, 5 to 300. You will be getting a long vector like this, right? You can try different values. So this is not hard. If you have any questions, please ask. Interrupt me and ask. Don't wait until I ask you whether you have question. You might forget, right? So please interrupt, excuse, and ask. That's fine. So I hope there's no issue with that.
Excuse me.
Yes.
Madam, what is the keyboard shortcut for execute a selected line?
A selected line, what you have to do is you have to highlight it, or either you have to place the cursor there, press Control and Enter.
Okay. Control Shift Enter to implement the entire thing, right?
I haven't tried that. Let me check. Control Shift Enter. Yes. Yes. Good find. Okay. Okay, so time to time, make it a habit to save your R script, because if there's an electricity interruption or any issues, we are working with machines. We don't know the inbuilt environment of this. We don't know. What we know is the outer interface. So it's always safe to save it, Control plus SU, or otherwise you can click on this, right? Whenever you compile something, it's better always to do that. So remember that time to time, save your script. Otherwise at the exam, if there were a practical exam for this, I don't know how that would happen. We'll see. If there were a practical exam for this, and by the end of the exam, if you don't have your R script saved, you're going to lose a lot of marks, sometimes 0. So always remember that, to save it time to time, because nobody is going to give you reminders on that. That is a good practice. Okay, then we are going to learn sequences. Sequence, right? This syntax, you can, if you don't know, you can type this, Control Enter, and in the help command, you'll be getting all the stuff that you really want to, right? What this has, argument. So the first argument is starting from. Second argument is to, from some value to some other value. By will give you from how much we are going to increase or decrease. We are going to print a sequence of numbers, right? Sequence of numbers. So by which number you are going to increase or either decrease. It's always not increasing stuff. Or you can either give the length, right? So there are so many arguments that you can give. There are worked out examples as well. So we are going to learn the most basic stuff. So if I want to print this, so let me write it for you. 0, 0.1, 0.2, right? Likewise, up to 1.5. Let's say I want to print these numbers. I don't know the length of this. I want to print 0, 0.1, 0.2, likewise, up to this number, right? How are we going to use the sequence command seq in order to print this? So when you type seq, you're getting the suggestion, just a matter of pressing enter. Then you will be getting a bracket also. It's easy. That is sort of an advantage of RStudio. Then the first argument that you have to give is starting value. So what is the starting value here? 0, right? And it is always comma separated, right? You can either write from equals 0, right? Or if you are using it without the argument name, you always have to go in order. You have to first give the starting value, then give the ending value likewise, right? If you write the name of this, you can switch between, doesn't matter. If you are writing 2 equals something from equals something, doesn't matter to make 2 equals something as the first argument, doesn't matter if you give this name. Otherwise, you have to follow the order, right? That is how this particular language gets interpreted on what we say, right? So this is the starting value 0. What is the ending value? You put a comma and you give the ending value. I want it to be 1.5. So I would give 1.5. What is the increase of this, or what is the gap between each and every number? I can see 0 to 0.1, the gap is 0.1. 0.1 to 0.2, the gap is again 0.1. So if I want a sequence like that, by how much? By, so that is the third argument. I'm not going to write by equals, or you can write it doesn't matter, by 0.1. So I am going to get, when I press Control Enter, I'm going to get the sequence that I really wanted to have. 0. So since I have a decimal place incorporated here, I am getting everything as a first decimal values, right? I can't help that. So 0, 0.1, 0.2, 0.3, likewise. This sequence has started from 0, ended by 1.5 in steps of 0.1. You can either give it, to be more precise, you can either give it like this, from equals 0 equals 1.5 by equals 0.1. You can try both the ways, you are getting the same thing. If you want to switch these things, still it is acceptable. We'll see whether it's happening. I'm going to give this one first. It should happen, we'll see. Yeah, still I'm getting the same thing. So it doesn't matter if you switch between by specifying the name of the inbuilt argument, right? It's okay. But if you are giving something like this, you definitely have to follow the order which is specified by default in R. Did you understand?
Yes, ma'am.
Okay, cool. So that is how you give out a sequence. So the syntax is basically, I don't have to write the syntax like this, right? Because it's given there, right? Always. So you can put up a note, just put an arrow here, wherever, take a piece of paper, write this, put an arrow here and write start. This is end. here you can write in steps of. So only for this I'm writing sequence. We can write start value, end value in steps of. Always save. Right. What if you want a decreasing sequence? Starting from a big value, ending from a small value, you want a decreasing sequence. So something like this. Sequence, I'll just give you an example. Sequence, let's say I want to start it from 6 and end it from 4, right? And I want to go in steps of 0.2. So if I give it like this, we'll see what's happening. See, it gives an error. Why? Because from 6, if you add 0.2, you're getting 6.2. You never can reach 4 there, right? Because this is a decreasing sequence. If you give like this, you're definitely getting an error. So since it is a decreasing sequence, you have to put negative sign. So the operation here is from the starting value, whatever the mathematical operation given in the third argument. So 6 minus 0.2 will give you 5.8. 5.8 minus 0.2 will give you 5.6. Likewise, until 4, this will give you the sequence. See, we are getting the sequence as we expected. Same thing, I just changed the values of these arguments. Starting value is 6, ending value is 4 in steps of minus 0.2, which implies we are having a decreasing sequence. Okay, what if we give something like this? So we can see the sequence has 6, 5.8, 5.6, likewise up to 4. It doesn't have the value 4.1, right? It has 4.6, 4.4, 4.2, and then 4.0. This sequence doesn't have the value 4.1. So what if we give 4.1 in the syntax? What will it give? I want the sequence to start from 6 and end from 4.1 in steps of this. What will happen? See, still we are getting 6 to 4.2, but 4.1 cannot be incorporated here because 4.2 minus 0.2 will give you 4, right? It doesn't stop from 4.1, but still this is mathematically valid because this sequence is greater than or equal to 4.1. The elements of this, any element of this sequence is greater than or equal to 4.1, less than or equal to 6. So we are getting something like this. So it doesn't matter where it really ends. What it takes into account is the starting value anyway they are going to have. The ending value, it really depends. You can either give the specific ending value or either you can specify the boundary, right? So did you understand that? If you don't know the ending value but still you want to have something around this, you can give a statement like this. It is logically convincing. If we want the same sequence in a different way, if you are asked to write this one in a different way, that it will output the same result. What is the next way that you can write? What is the next possible way that you can write? Do a single change to this statement where it never changes the output. If you are asked something like that, so you are going to have this output by doing a single change to this. You can put 3.9 here because we know it always goes with odd, even values. So this is an odd number, right? It should give the same result. It doesn't have 3.9. 3.9 is somewhere after this. If it was 3.8, it will give you 3.8. So we can't have 3.8. So the only possibility that you can get the same result by changing a single value is this one. This is equivalent to this one. And also when you're using the term the function, this is an inbuilt function in R, right? If you want to get a sequence from some value by some steps, but you do not know the ending value, but you know the specific length or the number of items that the sequence should have. In a case like that, still you can use this function, but with different arguments, right? Did you get my point? You know the starting value. You know in which steps it could decrease or increase, but you do not know the ending value. Still you want a sequence, but you can't be getting infinitely long sequence. You have to specify either the end value or either the number of elements that the sequence should have. In other words, the length of the sequence, right? If you know any three of those, this one, this one, this one, or this one, and the length of the sequence, you still can construct a sequence of values. So there you have to give the arguments because we are omitting this one, right? We don't know the ending value, right? We just want the computer to generate it. We don't know the ending value initially, right? We know this, and we know the length, right? So if that is the case, we anyway have to give out all these arguments. Otherwise, R is going to be a complete mess. Okay, so you give from, let's say I want it to start from 0.04, right? And it should increase by, let's say 0.01. So which means the first term is 0.04, second term is 0.05, third term is 0.06. Likewise, up to which value we don't know, but we know how many elements that this sequence should have. So we give the argument as length. Yeah, you can either give length dot out or even length, doesn't matter. We'll try both, right? Length equals, let's say I want to have 7. I want to have 7 terms in this sequence, right? So I'm going to compile this. We are getting 1, 2, 2, 3, 4, 5, 6, and 7 values, right? We didn't know this. We didn't specify this. Without even specifying the end value, there is a possibility that you can construct a sequence. So this is the syntax. Let's try length dot out. I haven't tried it before, just because it out. Yeah, it's given the same thing. So you learned something out. Even I learned. You can either give the length by length equals something or length dot out equals something. These are equivalent, right? So this syntax says length dot out. You can give it either way because length is again an inbuilt function in this R system. So anywhere you want a length, you can use it. That is the reason. Like we have, if you call it lexical scoping, we are going to learn it later, right? Using some function within another function. So this is a function, this is also a function, right? So we have used another function within this, inbuilt in R, right? So you can use either these. Both are correct. You could see both are giving the same response. Okay. So you can even give a decreasing sequence in this way. Let's see, I want to have started from 0.04, then I want to have 0.03, then I want to have 0.02. Likewise, I want 7 numbers. It will give you this. It's just a matter of giving this. I'm doing it very slowly, providing you time to try it yourself parallel to the lecture. I know it is just one computer screen. You have to see my screen. You have to watch my screen. You have to do it in your screen. So you can use this one, I think, this sign, and have the 2 screens parallel to each other if you're using a laptop. I'll see if I can increase the size of the screen. That's it. Is everyone okay with this? You can try other arguments also. There's some other arguments also in that sequence. If you go to help, they had a long dot width. So you can try it yourself. Within the syllabus, we are reaching only up to this point. But you can go through the examples. They have given examples, so you can try them. So it's unlimited. Since this is a programming language, we are not capturing everything. That is not the way a programming language is taught. We have millions of options here within one programming language. Even I don't know all the stuff here, right? So I learned from one of you once said Control-Shift-Enter would compile the entire script, right? So that I also learned it from you. So we are not even expected to learn everything, to know everything. We are expected to learn everything as much as possible, but we are not expected to learn everything. Usually when we are using these kind of languages in practice, this may be C++, maybe Java, any language in practice, what we do is we Google it. We Google for the inbuilt function and make our life easy. That is how we usually do. But at the exam, you have to know the basic syntaxes. Although this is open book because you are not given much time to turn pages, go through your notes all the time. So it's, these are basic, very basic stuff. It's an advantage to know your syntax. So be prepared for that as well at the same time. Okay, so if we want to create a vector, right, we can simply a type of this this sequence to make it a vector. So we are going to put this command. Even that is working. So there's no harm giving something like this. They take it When you go to help, you can see these 3 dots, right? 3 dot means you can pass arguments as many as you wish. Not only these, but you can pass other ways, other acceptable ways also within this function. That is what this means. This 3 dots means that, right? It's not always you have to give everything. You can choose between, but you have to provide the necessary information for them to build the sequence. There can't be more than one option when you give out a syntax. It always outputs just one option, so you have to specifically mention that. They have to have the necessary information to output to give us some value. Just give me a minute. Sarat sir is calling me. I have to answer this call. Until then, please practice this. Hello. Okay, the call is end. So, did you understand this? Any problems up to here? So far, so good?
Yes, ma'am.
Okay, cool. Right. So we are done with the sequence, and now we are after repetition. This is all about sequence. We are going to, if you want to have repeated data, you can anyway type, it's just assume you want 5 nines to be printed, you can give, right? You can give that. As long as it is just 5 numbers, you can give that. But what if you want to print 100 nines? Are you going to do this 100 times? If you are doing this, what is the purpose of using a programming language to create all this? No, we are not going to adopt this method if we have repeated data. We are going to make use of the function REP. Just like SEQ for sequence, we have another function in R called REP. So we are going to use that. So the first argument is the value that you want to repeat. If I want to repeat 9 5 times, let's say, so I'm going to have my first argument as this, comma, then you have to give how many times that this particular value should be repeated. So I want it to be repeated 5 times. I'm giving 5 here. When I run that line, I'm getting 5 nines. So without writing 9, 9, 9, 9, 9, 5 times, just by this command, I'm getting 9. So it's not a big problem to write 9 5 times. So, but what if we want to print this 150 times? Right? So we have to, it's always good to make use of the inbuilt functions like this. So if you want the to see the arguments, you can use here replicate elements of vectors and lists. So here also you have this one, right? And you have some other functions as well, rep.int. If you want to repeat integer values, you can use this one. So it is the same with this, even though I'll just decrease the number here. These are equivalent. If you want to repeat integer values, it will give out this. If you want to repeat any value, I don't think it works. I don't know whether it works. It works even for this, but it takes it as an integer type. It gives out these decimals as well, but the type of this should be integers. That is what this means. So if you want to repeat decimal values, don't use this one, because at some point when if you are using this, if you are not using this, it is just for the matter of showing it out, it's okay. But if you are using it in some complex calculation, it's going to add trouble to you. Sometimes it might not consider this decimal, although it is visualized here. So just get used to this one, because you can repeat any number. So you can decide on which arguments that you give, right? These two are equivalent. Get used to this. It's safe to use this. Right. What if I want to have something like this? I should have it like this. If we want to print numbers like this, still you can do this like this. But this is, yeah, we are getting the numbers, right? So this is not the way that we should use a programming language. If we can do this even manually, right? We can just type numbers, but we want to generate. It's not about typing numbers, we have to generate. So to do this, we still can use the command rep, repetition, because there is a repetition. You can see it is repeated in a pattern. It is repeated in a pattern. So how you use this is, you give the starting number to the ending number. So you have to start from 1 up to 5. You have to repeat each by 2 times. You can choose even to write it like this, or you can either write it 1 to 5, 2. Same thing. This is the default behavior. Usually default is this. If you give this to command here, the default behavior is this. That is why it gave you out the same output from this line and this line. If you read through this, you will realize. See, this is always by examples, they are giving you the default way that the function has been constructed. So if you give this one, this means 1 to 4, you repeat each value 2 times. It's something like this. If you print 1 to 5, you are getting 1 to 5. If you want 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, you have to repeat the same value. You have to repeat this one 2 times. So that is what you did here. Each 2 times. Did you understand?
Yes, madam.
Okay, good. If we want to repeat each block some number of times, so you're going to give it something like this. So if you want this thing to be repeated, let's say 3 times, still this is pattern data, right? You have some pattern here, from here to here. When you highlight something, it automatically highlights the same content throughout the R script. So that is another benefit of using R Studio over R, right? If you highlight something, you can see all the places. So when I highlighted this, you can see all these are highlighted. So at a glance, I can see this particular sequence is repeated 3 times. And within that, each element is repeated 2 times. So how are we going to have something like this using the replicate or the repetition command? You have to use another argument, right? So I'll give it as 1 to 5 each 2. So from this, we are going to have this set, and we are going to repeat that entire set 3 times. So we give times equals 3. We are getting this block, and this block. So you have to remember each command gives you repetitions within the block. Times command give you repetitions of each block. I hope that is clear. Right, okay. So the next one, there's another way of using this repetition command. Let's see what we are getting. So I'm teaching it other way around. Let's see what this means. Still, there is a pattern, but not consistent, right? I want to have 1 just once, 2 twice, 3 thrice, and 4 times. If I want that to happen, I have to give this command. So let's explore what this really means. So I will comment it out here. This is the output that we're getting. So what does this mean? This will give you 1 to 4 will give you 1, 2, 3, 4. And by this, we are telling them to repeat each by this number, right? You always know this is the first, if this is the first argument, second argument is this. That is why we could write this in the same way without using this argument. Just forget about this times argument. This is the block repeat, okay? The first argument is always the numbers that we want to have in our sequence or our vector, right? The second argument is the number of times each argument should repeat. If I want to repeat this vector in a different way, not in the same way. Here, this entire vector is repeated in the same way. 1, 2 times, 2, 2 times, 3, 2 times, 4, 2 times, and 5, 2 times. Always, every element of this, each element of this is repeated the same way. Here, I want to tell this to repeat each element differently. Right? If you expand this, you really can see this. I'll write it and show you. So what we have here is REP 1 to 4, comma 1 to 4. So this will give you the numbers. This will give you the argument each. So when we expand the first argument, you have 1, 2, 3, and 4. When you expand the next argument, again you have what? 1, 2, 3, and 4. Right? 1 is, I should have used another color. 1 is repeated 1 time. Then it comes to the next one, right? 2 is repeated 2 times. 3 is repeated 3 times. 3, 3, 3. And 4 is repeated 4 times. 4, 4, 4, 4. That is what this command did. From here to here, it uses the repetitions like this. Did you understand the mechanism of this? You can take a screenshot of this. Is that clear?
Yes, madam.
Okay. So let me share the screen once again. I hope you could take a screenshot or quickly write it down. Right. If I want something like this, now we are going to do this alone. I just did a small change here. I want this one by using the repetition command. How are we going to do? I'll give you time. You can type that syntax in the chat box and send a direct message to me so that others can't see what you said. Try by using the method, try to get this one. I want you to do it alone. Okay, I got one answer in the chat room, which is correct. A is 2018 343. Correct. Of course, he or she should also realize that it is correct because you might have gotten it by trying it out. Excellent. Others also don't ask from him or her now. Try to come up with the answers by your own. If you did understand what I explained in the whiteboard, you should definitely be able to get this. It's okay if not. After doing this, you would be able to. Doesn't matter. I'll give you more time. It's just a simple statement. Okay, as I'm getting another answer, I want to compile it and see. So I will off my screen sharing for the moment. I think you might have copied this down. Okay, it's also a good method. AS, what is this number? AS 2018-474 has got the answer correct, which is another way of thinking about this, which is very good, right? So there are so many techniques. So I'll put that up to others also. Please give a try. So the expected method was done by AS 2018-343. That doesn't matter. AS 2018-474, the answer is wrong, right? It's 100% correct. Expected means which I expected at this moment, right? Always expected answer is not going to be the correct one. It doesn't have to be, right? So both the answers are correct. So I'll share that answer with others also. Both the answers with others also. What about the other four? Try. I'll give you time. Try. Yes, another one has got the answer correctly. AS 2018-341, your answer is correct. And it is the same with the first one who responded. 3 more to go. Next one is 2018-308. Answer is correct. It's also the same way that the first person thought. Good. Is 2018-474. There's another method. You can try that by using the explanation that I did in the whiteboard just a couple of minutes ago. You can try that method as well. Yeah, your answer is 100% correct. That is acceptable. Even in the exam, your answer is correct, right? So don't worry. That's a new way of thinking. I just want you to inhibit the method that I taught you just now, just to make sure that you understood it properly. Five zero four answer is correct. 481 answer is correct. Okay, I think I have got 2, 3, 4. Okay, all 6 have answered, I think. Okay, good. Right, we all know the answer now. Let me share the screen. Okay, so the answer was by using this type. Let me check whether I'm recording this. Yes. Okay. So by using this method, right, the answer to get this is, the way of getting that is replication. I want the numbers from 1 to 4, right, in a way that 1 should repeat once, 2 should repeat once, 3 should be repeated 4 times, and 4 should be repeated 4 times. So one of your friends had answered it like this. Very good thinking, because this is very logical. You want a vector where 1 is not repeated, 2 is not repeated, and 3 to 4 are repeated each 4 times. So this is very good approach. Still you are getting the same answer. See, it's really good when we share answers, we get to know different methods, which one output is given out. So that is why it's not, you know, I can give you all the syntaxes to try it at home. Even this lecture could not be dragged for entire 2 hours. This could be done in 10 minutes, right? But I don't want to do that. That's why I told you to get ready, because I should give you a chance to try out. These are very small things, but when you are learning a programming language from scratch, it is always a good idea to practice. Just because we have time, it's better involving you in these things. Okay. Right. I hope everybody could approach the answers. Always there are outliers, which we have to accept. Okay. Then the next one is generating factor levels. I think I discussed a little bit about this last time. But let me go into depth there by using a function. Okay. So generating factor levels. So the syntax is this, right? GL. G means generate, L means levels. Okay, GL. First argument is up to which point, right? Second argument is with repeats of. Then you have to give two total length. These are the arguments. So let's see how we are going to make use of it. Right? So you can choose between, you can give this one and this one only, right? To get just one block, let's see. Okay, if I want to generate, so this also could be done using REP, repetition, but you know, we use this command to construct vectors. If we want factor levels, you cannot construct a vector, right? You have to have it as a factor level. The type of data should be a factor, not a vector, right? Vector is always numeric. So you can't use repetition command here if you want to have factor levels. Let's say, for example, 1, 1, 1, 2, 2, 2, 3, 3, 3, and let's say 4, 4, 4 for the moment. If I ask you to generate factor levels, you can't use repetition command. If you are using repetition command, you have to use something else as well. You call it cohesion, right? I'll teach you that in the next half of the lecture. So you are going to use this one to generate this sequence as factor levels. I want this to be factors. The data type should be factors. So GL, generate levels. I'm going to give up to which number. I want it up to 4, right? So my first argument is 4. With repeats of how many? One argument should be repeated 3 times. So with repeats of 3. To length of, how many times do I need to repeat this sequence? Just once, right? So you can either give 1 or you can just omit that. Okay, and by this one they take it always from 1, starting from 1. Factor levels, why do we use factor levels usually? To code data. You will understand when we create a data frame at the end of today's lecture, right? So factor levels means it's just a category, sort of, right? So for example, if we have 2 categories, male female, to the variable gender, we can denote females as 1, males as 2. So always start from 1, 2. You don't code it like 2, 3, right? Females 2, males 3. Then what about 1, right? So usually the usual norm is starting from 1 when you're labeling the factors, right? And this is just labeling something. So that is why in R, by default, they take always the first factor level to be 1, right? In R, they take it as the first factor level always 1. That is why you have to give the ending value only. And you have to give how many times it is repeated. So here, what are the levels? You have 4 levels, 1, 2, 3, 4. And this is the data set. 1, 1, 1, 2, 2, 2, 3, 3, 3, and 4, 4, 4. Okay. You can either give it like this if you want to learn this syntax, because we omitted this argument. If you want it 1 times, just give it to me 1. So these two are equivalent. Oh, no. No, you cannot give that. So this means you have 4 factor levels, you have extracted 1. So that is not going to work. Right. So if you want to have just 1 block of this, you are going to give GL, comma, this, right? So if you want, let's say you have a data set of 100, so you are going to assign the first respondent 1, second respondent 1, third respondent 1, then fourth respondent 2, fifth respondent 2, likewise 100th respondent. You don't know whether it is 1, 2, or 3 or 4. You don't know, right? In repeats of 3 when you go. Anyway, let's say you have 100 people. So you have to have 100 numbers, right? That is when to total length. You have to have 100 numbers, right? So if that is the case, you have to give it like this. See, the 100th person is getting 2. When we assign people numbers like these, sometime, so 100, 99, 98, 97. So now by 96, you have you have maintained this pattern, right? 97 should be this, 98, 97 is this, 98 is this, 99 is this, then 100 is this. 101st person's factor level is again 2. 102nd person factor level is 2. 103rd person factor level is 3. So you have to continue this pattern. But still we have 100 respondents, right? So we have to stop from the 100th value. So basically, if we want to use 3 argumental method, I should have need like this. Okay. So if you want to have this one only by using 3 arguments, what you have to do is, so how many elements are there? You can simply get it by length of this. You can either count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can either count it like that or get it by a command, right? Length of this, length within brackets, you have to give the vector. Right, length of this is 12. Okay, so if you want to have this with 3 arguments which satisfy this syntax, you can simply give this to be 12. Still you are getting the same thing as this. Or you can either say you don't have to find the length separately, right? You don't have to find the length separately. What you can do is, so this is method 1, this is finding the length and then giving this. The third one is you can have this command on behalf of this argument. Still you are getting the same thing. Did you understand what I did? I got this using 3 different methods. So this is, I'll name it as method 1. This is method 2. And this is method 3 of getting this. Did you understand what I did here? This one. Do I need to repeat it? This is just one line which I have used to give the output which is given by these 2 lines. Same thing. What I have done here is I have found the length of this array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that is 12. I compiled this and got the answer as 12. And simply I put that value here. Just for the sake of getting this. I have 12 people in my experiment. So for all those 12 people, I have to assign some factor level. First person 1, second person 1, third person 1, fourth person 2, likewise. 12th person 4. I have to assign the values. So prior to anything, I know my sample size. I know how many respondents that I have. Here, by this, actually this one I don't know. What I get is 4 times 3, 12. Because the last one is 4. I'm starting from 1 and each element repeated 3 times. So 3 times 4 will give you the length of this actually, right? You don't have to even count it. You can just take 3 times 4, right? So here what we did was, without manually counting it out, you got the length of this and you recreated this. If you have 24 people here, you just have to put 24 here. Then this block is repeated 2 times, 12 plus 12. Okay. If you have 100 here, that particular block is not really the block. That particular, you have 100 elements there. Okay. So likewise, here what I did was, first argument is the ending value. Second argument will give you the number of steps a particular factor level is repeated. Third argument gives you what? Total length, total number of respondents. So that will be given out by length of this one. Same thing. So Just use the arguments here and there in a way that you can produce the same. So is this clear? Did I confuse you?
No, madam, it's clear.
It's clear. Okay, thank you. Right. So you learned something out here. You can use again a function within a function. Okay. So this is generating factor levels. Do you understand the difference between a factor level and a vector? Vector is always numeric, right? It's a vector. You have the values, sequence of values. Factor levels mean you same thing, but you are getting levels. They are categorical variables actually. They are categories. These 1, 2, 3, 4 are not numeric values. They are categories. Educational level, you have O level, A level, scholarship, O levels, A levels, degree. Let's say 4 levels. So 1 for scholarship, 2 for O level, 3 for A level, 4 for degree. Those are not quantitative variables, right? You all know, you have done the mathematical statistics courses before. So you all know, although you give 1, 2, 3, 4, they are, although you assign numbers to those categories, still they are not quantitative variables, they are qualitative. They are ordinal variables, right? You all know nominal, ordinal, interval, and ratio variables. So nominal scale and ordinal scale falls into categorical variables. Nominal scale, we have categories where the order is not important. Ordinal scale, we have categories where the order is important. When it comes to interval and ratio scale, those are the quantitative variables. Quantities, we are talking about quantities. Here we are talking about qualities. Although we have 1, 2, 3, 4 here, they are just levels. They are just categories. So that is the idea. That is the difference between a numeric vector and a factor level. Okay. So if you are asked to get this type of a sequence as a level, factor level, do not use repeat command, because this always gives you a vector, a quantitative variable. What you want is a qualitative variable, so it's going to be meaningless if you get this output using the replicate or the repetition. Okay, so make sure you don't make that mistake. Learning the data types is always very important, right? Okay, so we'll quickly do naming of factor levels next as the next one. So let's say we have just for example, we have 24 respondents. We should assign 1 to 4 as factors for them in repeats of, let's say we want to do this, right? If that is the case, what we do is simply put 24 here. We are getting 24 values where these are assigned. Like that. Okay, next one we are talking about factors. Before that, naming factor levels. Right? We can give labels for these, just like scholarship, O levels, A levels, degree. Likewise, you can give names for these, because that is what they are meant to. They are not 1, 2, 3, 4. They meant to something, some category. So we can name it. So let's say temperature. I'm giving you out an example, temperature. So we are going to have a low temperature and high temperature, right? So there are 2 categories. So you are going to generate levels for 2 categories. That means up to 2, 1, 2. Okay. 2 categories. Then the next one is in repeats of, let's say we have, we'll take this example. We have 24 respondents here also. Let's take it like that. Let's say we have 24 respondents, right? And we need to repeat the same factor 1 1 2 2 1 1 2 2 1 1 2 2 likewise. Okay, the first respondent 1, second respondent 1, then third respondent 2, fourth respondent 2, fifth respondent 1, sixth respondent 1. Likewise, I want to have ones and twos, but I want to generate it not in terms of ones and twos, but giving them some labels as high and low, high temperature, low temperature. So you have to use, so we have 24 respondents here, and you can still give some other arguments. You can say labels is equal to, you give it as a vector. Within inverted commas, the first one is low, second one is high. If we give something like this, let's print and see. You are getting high, low, low, high, high, low, low, high, high. Likewise, you are getting 24 elements. What are the factor levels here? 1 and 2. 1 is assigned for low, 2 is assigned for high. Just because we assign labels here, you are seeing these as low and high words. You are seeing these as words. If you didn't have this argument here, you are seeing this as 1 1 2 2 1 1 2 2 likewise, and the levels are 1 and 2. Okay, so this is naming the factor levels. If you don't want to have ones and twos as factor levels, if you want to give them out some meaning, you can use this method. Same way, let's say we have I'll name the variable as soft hardness. Okay, hardness. So I have 3 hardness levels. Let's say soft, medium, and hard. Okay, soft, medium, and hard. So I have 3 levels. So I want 1, 2, 3, up to 3. Okay, and I want them to repeat as let's say we have 24 and 3, let's say 8 times. I want to repeat 1 8 times, 2 8 times, 3 8 times. So again, we are getting 24, right? I want to repeat one variable 8 times, and I'm giving out the labels as hardness levels. So it's hard, medium, soft. Hard, medium, soft. Yeah, and I'm going to compile that, and let's see whether we have properly. Yes, the 3 levels are hard, medium, and soft. See, for the first 8 components, I have gotten hard. The second 8 components, I have gotten medium. Third 8 components, I have gotten soft. Okay, you can do it. Then let's say I'm going to incorporate some brand, just random variables. Okay, just the random variables that I'm getting to my head. Brand, and I want the brand to be let's say small and medium, right? No, let's say size, small and medium. So small and medium are 2. So one for small, 2 for medium, let's say. Right, and I want it to be repeated just one after the other. Small, medium, small, medium, small, medium, small, medium. So I want to repeat each word only 1 times. Then I have 24 respondents. 24 times I have to have that. Then I'll give the labels as, let's say, small and medium. Small and, let's say, it's better to say regular and large. Yeah, it's okay. It's okay. Small and medium. Just for the example. So let's see whether we have gotten it properly. Yes, small, medium, small, medium, small, medium, likewise. So these are the factor levels. Now I'm going to put them all in a data frame. Let's denote it as df. You can give any name here. You can give any name here, any name there. And I have to have the data frame as data.frame. You learned this last week, how to create a data frame. You are going to combine all these factors in one data frame. So you're going to have temp, then you're going to have hardness, then you're going to have size, and you're going to print this data frame. This is what you will be getting. It's just like a data set that you created. Temp, hardness, size. So this is the first respondent. This is the 24th respondent. See, you have a data set here, an entire data set. Likewise, you can code and create data sets. This is just one purpose why we learn to create pattern data and factor levels, of course. We have to give it the correct data type. Otherwise, when we are manipulating, we are coming across problems. So we have to specify the correct data type. That is why we specified these to be factor levels. You can add different other columns to these. Reading, maybe their color, size or something. So that is going to be a numeric vector. It's not going to be a factor level, right? So likewise, you can create data frames like this using factor levels like this. And also by using the command factor, generating factor levels. So there's another method of generating factor levels. GL is just one way, or you can use the word factor, right? Let's denote X factor. Let's say you want ears and nose, right? So I'm just hard coding it. Yes. No. Yes. Just in a random order. Let's say we have something like this. So when we print X again, it is going to give us yes, no, yes, yes, no, yes. Something like this. But not in a pattern, right? It doesn't have a pattern, it's in random order. We can't see a pattern, so we use the word factor there. This is just one way. So if you want to count how many ears are there, how many noses are there, the easiest way of doing it is constructing a table, right? So you use the command table of this variable X. When you print that, you are getting there are 2 no's and 4 yeses. It always comes in alphabetical order, irrespective of the order that we give here. Doesn't matter. So if you construct a table, you can count how many no's and how many yeses. See, we have 2 no's and 4 yeses. Likewise, you can do anything for that. Even for these, you can do it. If you want to count how many, here, of course, we have given it even, so it's no point counting these, but doesn't matter. We have 12 small and 12 medium, right? Here we have 8 hard, 8 medium, and 8 soft, so whole lot even, right? But still, we can give that command. Table, we can say hardness, let's say. See, 8, 8, 8, right? But there's no point because we know the count. That's why I didn't specify that. Anyway, for generating levels GL, you can use this table command. I wonder whether this is working. Yeah. If you get a table for the entire data frame, you're getting something like this. So when size is equal small, you're getting a 3-way table, right? Size is equal small, this is what you call a contingency table. You have two variables here. When size is small, temperature low, high hardness, this, you have this combination. Low and hard 2, low and medium 2, when size is small. You can read it from the table as well. When size is small, you filter out all the small sizes, right? Low hard, you just have 2 counts, right? Likewise, you are getting, when you construct the table for the data frame, you are getting a 3-way table like this. You call it a 3-way table. You take one variable and under one category, how the other 2 variables change. You take size is equal to medium. You see the contingency table between the other 2 variables. So that is something extra you can try out at home. I'm anyway going to give you out this script, so you just take a look at this. When I tell you to try, you can try things. Otherwise, don't copy the R script always to your script, because you are not going to learn if that is the case. When I give you time, you can try. Otherwise, you can look at the screen. Okay. Cohesion is, okay, you are going to learn a new thing now. We call it cohesion. Cohesing something means you are changing the data type. Okay. Right. So let's take some variable x. It's okay to have x here and x here. When you compile this line, it's going to be something separate, something different. Okay. When you compile this line, thereafter the variable x is taken this value, but not this one. Okay. So that is why it is always a good practice to use different variables for different names, rather than using the same variables, because it is going to be overwritten. Here, when you compile whatever the line that I'm writing here, x is no more this one. It is the new one. Okay, it overrides. But for this, I'm using it. So let's say I want to have a vector of true and false. So, do I have to give it like this? I don't think so. You have to give it in capital letters if it is true and false. True, false, true, false, false, true. Let's give something like this. We print, sorry, simple x. If you print this, you are getting true, false, true, false, false, true. Although it is t, although you give it as TRU in all capitals, you will be getting this one. You learned it last week. Okay. So if we want to see whether true and false are their logical, no, they're logical type. We learned it last week. So if we want to see whether this is logical, the command is dot logical. We can give x. It should give us true, because this is a logical vector, right? Is this numeric? We can check. Is dot numeric. Numeric means numbers. So is this numeric? False. It's not numeric. It is a logical one. If it is logical, it's nothing else, right? Is this a factor? Is dot factor. No, it's not a factor. It's neither a factor, right? But what if you want to make this a factor? Let's say you have some logical vector that is logical, that is neither a factor, neither a numeric, nothing. It's just a logical vector, right? What if you want to make it a factor without again defining it as a factor? Without doing this one, if you have this in your hand, how do you make it a factor? So let's say it is y. You can either keep the space or not. Y. I'm going to make x as a factor. So as dot factor will coase x from logical type to factor type. Let's print y. See, you are getting factor levels. Earlier, you just got the vector true, false, true, false, false, true. Here, you are getting it as factor levels. So, y is logical, x is logical, y is a factor. So, you can check it. Is not logical. Is y logical? So, y is true, false, true, false, false, true. Is it logical? No more. No, because we coerced it to a factor. Coercing means changing the data type, right? Is it a factor? Yes, it is. It's true. It is a factor. Hereafter, it is a factor. That is what you call by coercion. So let's make this a numeric vector. Right? Always true is 1, false is 0. No? Binary values. No? So let's take another variable as z, and I'm going to convert it as dot factor. Sorry, as dot numeric. I want to make it numeric. I want to give it numeric values. 2x. Let's print z and see. You should be getting ones and zeros. Ones where there are true, 0 where there are false. So here also you can check all these. You can simply check all these. Is it a logical one? No. Is it numeric? Yes. So it gives up true. Is it factor? No. Did you understand this?
Yes, madam.
Okay, good. Okay, now we are discussing how to remove missing values. And A means not available. You can either say it's missing. Let's say you have a vector x, right? So it is, let's say, just give some numbers and some NAs also. Something like this. So when you print x, you are getting something like this. You always don't have to print it. Why I'm doing it? I just want to see whether I have typed the correct thing. That is why I want to print it all the time. It's not a must. So let's say I want to take off these NA values. These are missing values, right? These are missing. I want to take off these missing values. So how am I going to handle it? First, I'm going to, let's denote another variable, NA status, let's say. You can put any name, right? I'm going to check whether is it an unavailable value. So the command is is.na, just like is.factor, is.logical, is.numeric, just like that. I'm going to check and assign it to NA status. If I print this, let's see what we are getting. So is it an NA? No, false. Is this an NA? No, false. Likewise, 1, 2, 3, 4, 5. Fifth one. 1, 2, 3, 4, 5. Yes. Fifth is a NA value, so you're getting true. Sixth is a NA value, you're getting true. Seventh is NA value, you're getting true. Eighth one is not an NA value, you're getting false. False, false. The last one is also an NA value, you're getting true. So what you're going to do is you're going to subset. You are going to extract all the NA values and subset X. So how you are going to do is okay, let's do something like this. X. I'm going to select this square bracket means selecting, right? I'm going to select all the NA values. My intention is to what? Deselect all the NA values. But for the moment, I'm selecting all the NA values. That means I'm out of this X. Out of this X, I'm going to choose NA values only. I'm going to select. That is what the square bracket means. Okay. When I compile it, I'm getting all the NA values. But this is not what I want. What I want is excluding all the NA values and extracting all the available values. So it's just a matter of copy pasting the same thing, right? You put a exclamation mark. Exclamation mark usually means not. The opposite of what we want. So I am extracting or choosing or selecting non-NA values from X. So this will give me the desired answer. Removing NA values. So you don't have to do this step, right? You can simply, out of X, you can extract this. So in one line, how you are going to write it? In one line, you have to write X, right? You have to take away, right, all the NA values. So I hope this should work. Yeah. All these are, sorry, from here to here. All these are shown in just one line. So this is method 1. Same thing, method 2. This is just assigning things to a variable. Is.NA is this. That is this. So this is this. At the exam, you can either choose to write this or this. If you are asked to do something, you can choose between, doesn't matter. If you're asked to write it with one line, you have to use this method. If you're not specified, you can use any. Even if you know how to write this, you know to take it to one line, right? It's just a matter of looking at this. You have to assign a value to this now. What is NA underscore status? It is simply this one. So you took this one, you assigned it here. So if you can write this by thinking logically, if you can write this somewhere, you can anyway represent it using one line. Okay, the last one in today's lecture, that is omitting missing values in a matrix. Okay. There's nothing big, you know, if you can do it to a vector, you can definitely do it to a matrix. So let's have some matrix M. You know how to give a matrix command, right? Let's say we have 100 elements. It's quite big, let's have it like that. And then we have 10 rows and 10 columns. Okay, so I'm giving if you want, you can print and see, otherwise no need. See, we have a column-wise matrix, just a default one. You can either choose to print it or not. Okay, then I'm going to do something for this. I'm extracting, sampling some rows. Oh, I didn't teach you the sample command. Okay, before that, I have to teach you one thing. Sample command. Sorry, I missed that. Sampling means you are randomly extracting things out of the given domain. That's basically what sampler is. Okay, let's say so this is the syntax: X, size, and some things, right? You want to sample, you want to extract a sample from values 1 to 20. Let's say you have a vector of 1 to 20. You want to take out 5 values out of that vector. So you are going to give sample 1 to 20. I want 5 values. So when you compile it, I'm randomly getting 2, 11, 18, 9, 13. So this might not be the same thing that some other person would be getting. If I compile the same statement again, you are getting some other numbers. See, you are getting a random sample. So this is the same command that I compiled here also. Right here, when I compile it once again, I'm getting another set of values, but between 1 and 20. So this is important. Please write this because it's all going with randomization. Extracting a random sample given the size and the data range from R, this is the way. So whenever you compile this, you are getting different combinations of numbers. So this is random sampling, right? So just write it. Write these 2 lines also. Compile the same thing and see everything different values between 1 to 20. If you want one value from 1 to 20, see, first time I'm getting 5, next time I'm getting 12, 14, 10, 9, again 10. See, you want 3 values. You can simply try that out. Okay. Now you learned that. Now you are going to omit missing values in a matrix. So I'm going to construct this matrix. If we print this one, you can just highlight a partial proportion of this line and even compile it. Doesn't matter. Right? You are getting this one. And for rows, I'm going to have a sample from let's say 1 to 10. I have 100 numbers here, right? And I have 10 rows and 10 columns here. So I want to sample 10 values. And I'm using the replace command because I choose a sample from 1 to 10, a sample size of 10. Okay, from 1 to 10, I'm going to choose 10, right? And replace true here. Right? If I print this, see, from 1 to 10, I'm getting these, and it is replaced as true. Okay, this is just taking a sample. Then taking columns, let's denote it as false. Again, I'm going to do the same thing. Right. You can either choose to replace it as true or just keep it like that, doesn't matter. Then you are going to use another command called column bind. Okay, and I assign it to a variable called art. Column bind is always binding columns. So this is just one, this is another one, right? So same command compiled 2 times. You can so replace true means with replacement. Replace false means without replacement. Okay, so you can see out of these 10 you have replacements, right? This is repeated, this is repeated, so this is replaced. You pick out a number from 1 to 10 and you replace it back again in the bag. Then you are again randomly picking out another number from 1 to 10. That is what you call replace making true. Okay, if this is false, when you extract number 4 for the first time, you never extract that number again, right? But I don't want that to happen. I just want it with replacement. That is why I gave replace equals true when drawing the sample with replacement. And I am going to assign it to rows and columns. So this is just a variable. I have not assigned it to matrix yet. Okay, and I have to have these as columns. So I am going to call the function cbind. Cbind is for column bind. Cbind rows and cols, the variables that we created here. So when you compile this, you will see rows, columns. So these are binded as columns, binded together as columns, right? These are just vectors, sampled vectors. These are this one and this one have been binded as columns, rows, cols, likewise. Okay. And for these values, for these rows and columns, I'm going to assign non-available values. So in M, we select R, which means in this matrix, I am going to select these values, right? And assign NA to those. Okay, and then when I print M, I am getting a matrix with NA values in some places. See, some places means when a row, that means what? I have always to a matrix, I have to give the row index and the column index, right? So when I give R, we printed this and we printed this and we have this. Okay, 4th row 9th column should be an NA. 2nd row 9th column should be an NA. Let's see, 4th row 9th column. That is why I gave R here. So R is a 10 by 2 matrix again, right? So here this means 4,9, 4th row 9th column. When you go to this matrix, 4th row 9th column is an NA, right? So when you go here, 2nd row 9th column is an NA. 2nd row 9th column is an NA, right? This one, 4th row 10th column is an NA. So this is repeated 2 times, doesn't matter, same thing is going to be NA, right? 4th row 10th column, 4th row 10th column is an NA. Likewise, for all these, they have assigned NA values. I just constructed some matrix initially and randomly assigned NA values to here and there. That's what I did out of all these, right? I'm going to teach you another command, complete.cases, right? I'll just denote it as D, complete.cases of M. Now our new M is this because we assigned it to M itself. We didn't assign it to another matrix. We assigned it to M itself. Okay. If we compile this command, you are getting true, false, likewise. So from there, what you get is, so this doesn't have any column wise true, false thing. Okay. So complete dot cases means whether this first column is complete, true. Second column is complete, true. Third column is complete, true. Fourth column is not complete. Am I getting it column wise or row wise? Sorry. It's giving it in row wise. It takes the first row. It is complete, no NA values. So it is true. The complete cases always give row wise. Okay? Row wise. You take the second row. Is it complete? No, because there is an NA value, not available value. So it should give you false. You go to the third row, it is true. Third row is true. No NA values. Fourth row should be false because it has a couple of NA values. 1, 2, 3, 4. Fourth is false. Fifth is false. Likewise, you are getting true and false statements for each row. So you should have 10 true false statements for 10 rows, right? First row, second row, third row, fourth row. So by this, what we do is we extract the rows. We can extract the rows where it doesn't have missing values, right? So the idea is this. Initially, we have a matrix with not available values, with missing values. We are going to extract all those rows and have only the columns, rows which have some value without any values. So we do from our new M, from our new matrix with not available values, I'm going to select all the complete rows. This will give you true, false statements. So I'm going to select true ones, right? With all the columns. So we are not going to give anything here. This will give you 6 true rows. 1, 2, 3, 4, 5, 6. We have 6 true and 4 false. See here, we have all the columns. We didn't give any command here. All the columns, but only true rows. True rows means all the rows that we don't have any not available value. Let's say we want to find the rows which has NA values. I think this should work. Let me try first. This is just a try out. Yes. So I want to extract the rows which has NA values. So it is the second row, fourth row, fifth row, and the last row. So out of M, I'm getting the second row, fourth row, fifth row, and the last row, which has NA values in it. So this is what selecting from a matrix means, right? So this is, we are getting the complete cased one. Complete cases means you have all the values there. Not this means you have incorporated non-available values in your final matrix. Is that understood? This is just about assigning NA values to a matrix, extracting non-NA and NA values out of a matrix. Always you have to specify the column name and the row name when you are extracting things out of a matrix, unlike the vector. So is that understood? This is the last part that we discussed. It's almost 3:05. So is that understood? Is that clear?
Yes, madam.
Okay. So if you don't have any questions, you can leave the meeting. Thank you very much for participating in today's lecture, although it's a public holiday. I'm not always going to have lectures on public holidays, but still here I really couldn't help it because I'm on leave on the first week of November. That's why I really covered this. Sorry for that, but thank you very much for participating. If you don't have questions, you can leave the meeting or else you can ask. Thank you very much. Stay safe.